All right, Algebra 2. We are talking about some of the same stuff we've been talking about. We did systems where we're trying to figure out like when two lines cross, or we also talked about when three lines cross, what's the intersection point. So what we're talking about here is when a quadratic and a linear function cross. So you can see in these examples, like these two are going to cross at two different points. So the, solutions would be 0, -3 there, and 4, 5 right there. So it could be two answers like that. Okay, so two answers, and then your two answers are x, y, x, y. So 4, 5 is one of them, and 0, -3 is the other. And so the second one, again, we just have two separate functions. We don't really care right now about the equations themselves, but what we're looking at is the equation. So this crosses only one time, and it's right there. So one answer, and that's at -2, 5. Okay, and so the last one, you can see the line is not crossing at all, so it's 0, and the solution is no solution, okay, because it doesn't cross. And so those kind of should look familiar, a little familiar, because we worked through a lot of systems like that. But now with the quadratics and the linear, we got to kind of think about like how this would be done without a graph. So this is the graph, and just one more example here of a quadratic and a linear. And here's your two equations. So I've got this and this. So how many times does it cross? Looks like it's crossing twice. And I can see those right here and right here. And those are -1, -1 for the lower one, and -5, and up it looks like 7. Okay. And so how do we do that without a graph? Well, that goes back to what we've basically been doing. Okay. And so to do that algebraically, we're doing kind of the same stuff we did with solving equations, except we're not going to be able to do elimination. So what you're going to do is substitution. What you'll notice on number 1 here is both of these are y equals blah, 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 and y equals blah, blah, blah. So since they both equal y, you can set these equal to each other. Okay, so basically what I'm doing is, since y equals all this, I'm going to plug it in for y in the other equation. So instead of saying the bottom equation is y equals -2x minus 3, I'm plugging this in right here. So x squared plus 4x plus 2 equals -2x minus 3. And then you solve like we've been doing in class. So first step is always to get it equal to 0. And so I'm adding 2x, and I'm also adding 3 to get it equal to 0. And so I have x squared plus 6x plus 5 equals 0. And so now we have the same choices as we did last chapter. Those choices are quadratic formula, factoring, or completing the square. So I'm going to just factor this. Since I have a 1 in front, this is going to be a little easier factoring. What two factors of 5 add to get 6? 1 times 5. So x plus 1 and x plus 5. And we end up with x equals the opposite, -1 and -5. Okay. Now, the difference is, now that we have 2 points potentially, what I have to do now is take those x values and plug them in to figure out what the y value is that goes with it. So I'm going to use that bottom equation and say y equals negative 2 times negative 1 minus 3. And so I end up with 3 minus 3, which is, or sorry, bad math. Negative 2 times negative 1 is 2 minus 3, which is negative 1. So my first point is negative 1, negative 1. And then I do the same thing for this one. And so I plug this x in to the same equation, y equals negative 2 times negative 5 minus 3, and I end up with 10 minus 3, which is 7. And so you see that we get the same answer as we did before, negative 5, 7. And so it's that same problem we just saw in the graph, but we did it algebraically without knowing what the graph looked like. Okay? And so there is our two answers. Okay? So let's go through a couple more, and then I'll give you some time to try some of those on your own. So number 2, we've got y equals. So I'm going to take this, plug it in for y. So this is going to be x squared minus 53. Sorry, I don't know why that looked like that. Okay. Y squared minus 53 equals 3x plus 1. So again, I'm just setting the two equations equal to each other. So I get it equal to 0 by subtracting 3x and subtracting 1. And so I have x squared minus 3x minus 54 equals 0. Okay. Now I'm going to factor it again. 1 times negative 54. Negative 54. I know it's not 1 and 54, so let's go through some different numbers here. If I divide by 3, it's 18, I think. 4 doesn't work. 5 doesn't work. 6 times 9. So there is a difference of 3, and I want negative 9, so that I get 6 minus 9 is negative 3. So x plus 6, x minus 9 are my factors, which means my answers are the opposite. So I've got x minus 6 and x equals positive 9. Okay, and so once again I take both of those and plug them in to one of those two equations. And again, you just pick the one that is going to be easier, so the one without a square. So y equals 3 times negative 6 plus 1. And so that's going to be negative 18 plus 1, which is negative 17. Okay, so there's my first point. Okay, and then I'll do so that's negative 6, negative 17. And then I do the same thing for this point. So y equals 3 times positive 9, sorry. 3 times 9 this time, plus 1. And so y equals 27 plus 1, which is 28. And there's my second answer. So 9, 28. And so you can kind of see why we can't just rely on a graph, because neither one of these points would be very, easy to see on a graph. Okay. So let's do one more here, and then I'll let you go with some of the practice problems, and then we'll talk about the last one tomorrow before we go to Thanksgiving break. So number 3, I don't have y by itself here, but what you do in both equations, what you do have is this. So I can plug this in since it's equal to y and plug it in right there. So I've got x plus all of that I boxed, so 3x squared minus 8x plus 5 equals 3. So two things I'm going to do here. Combine like terms and subtract the 3. Get it equal to 0. So in front I have 3x squared. Combine these like terms, I get negative 7x, and then 5 minus 3 is 2, so plus 2. Now I have another trinomial that I can kind of figure out what I'm going to do to solve. Now this one's an easy factoring problem, but since we've been doing factoring this whole time, let's go ahead and try one out with quadratic formula. So I've got a, b, and c. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. And I'm very tone deaf. All right. So let's put the b, negative 7, in the first two spots. A is 3, next two spots. C is 2. And so one thing at a time, I got positive 7 in front since it's a double negative there. Square root of something over 2 times 3 on the bottom is 6. So when I work that out, what's that? 12, 24, 49 minus 24, 25. And so 7 plus or minus 5 over 6. And when I get my two answers, I have 12 divided by 6 is 2. And then 7 minus 5 is 2 over 6, which is 1/3. And so now I have my two x values, okay, to plug in. And so I'm going to go ahead and plug them into the bottom equation for x. So keep in mind, those are the x values. Okay, so I'm going to go here. It's 2 plus y equals 3. So for that first one, y equals 1. And so 2, 1 is my first point. And then my second point is 1/3. So when I plug that one in to the same equation, I get 1/3 plus y equals 3. Subtract 1/3. I get y equals 2 and 1/3, or that would be 9 minus 1, 8 over 3. You could do 2 and 1/3, 2 and 2/3. Sorry, not 1/3. 2 and 2/3 or 8 over 3. Either way, your point is 1/3, 8 over 3. If you had rounded decimals on that, probably would be okay, but try not to round if you don't have to. Okay, so my suggestion would be to try that last one, and then we'll talk about that tomorrow, and then we'll have you have the rest of the time to get started on that homework worksheet. Okay, so I'll see you tomorrow, and then we're off to Thanksgiving break.